Okay, thank you all. 2 lectures in 1 week. Apologies. We'll do it again next week. Tuesday and Thursday next week. Next week, Annabelle Seldorf, fantastic architect, beautiful buildings, great speaker. If you haven't seen her lecture before, as I said last time, if you look on our website at the archives, you can see a videotape of her commencement speech she gave last year, actually. And she lectures on Tuesday, 5:30 p.m., and Roger Sherman lectures on Thursday, 5:30 p.m. So thanks for coming. We have a special treat tonight. This is the only time we could get our speaker, so we're lucky we got him tonight, and we're lucky and very happy you're here. I'm not going to introduce him. I'm going to introduce Professor Fei Wang, who is a friend of his and who has worked with him on a couple of projects, and he will make a more formal introduction. But thank you. So we'll lecture for about an hour, and then we'll have questions. And that's it. Fei.
It's my pleasure to introduce Michael Peng, and his Chinese name is Peng Wu. He prefers his name Michael and Michael. And so he's not new to SU. I invited him to come for the 409 final review in the past May. So it went well, and he wanted to come back again. So he's a long-term friend and collaborator. We've been working together on a lot of projects, also been teaching together for several universities. So I can introduce him better than any other people. So he's a senior associate at Gensler right now in San Francisco, but he was in charge of, it's a shot from this building, Shanghai Tower. Right now it's the 2nd tallest building in the world. He was in charge of the project for 7 to 8 years until recent completion. And basically he was in charge of all the conceptual design and to the parametric design of the facade, also incorporate with all different systems together. So this is one of the most important project on parametric design. Also, it was actually built at the largest scale so far. Michael also has authored numerous essays on parametric design and has lectured this topic at many universities internationally, and also different seminars, including Germany and New York City and Chicago and a lot of places in China as well. He's also one of the founders of China's, I don't know the full name, I cannot find the full name, it's China's Parametric Architecture Association. So he has been working on many symposium and workshops across China in Beijing, Shanghai, and many other places. And also he has taught together with me several universities and University of Hong Kong and China Academy of Art in Hangzhou. And we have 2 students here, and his former students and mine as well. And also Shanghai Jiaotong University. He had a fine arts training before, and he has a lot of cross-disciplinary research and practice. Besides his office work, he has a lot of really interesting practice related to arts and architecture and many other issues altogether. Also, right now we are trying to collaborate on another really interesting project working on jade. So without further ado, please welcome Michael, and basically he's going to talk about this his newborn giant baby. Please.
Thank you for this nice introduction for me. And then, so because this image doesn't show the tower, but it does show the shadow of the tower, like here. It tells me this building, like us, is silence, is never moved, but shadow moves as always. And especially like when the seismic, like earthquake happen, or a typhoon came to Shanghai, because Shanghai is actually in the typhoon zone. And then this building, especially at the top, will move like that way. And then this range is like 1.5 meter. So the building has life. So to kind of solely this movement, because when you are not use any kind of way to reduce this, people will feel it. Especially the people living at that top. I think if we have any kind of facility on the top, 70% will feel the tower move when the typhoon came in. So we have 1,000 tons steel hanging at the top. Goes like that way. If say this tower, and then this steel mass is hanging at the top. And then I may show you a video how that thing works. It's really quick experiment I did in my bathroom. Sorry, it's kind of rough. Like this, the structure of the building, right? So if typhoon came in, it's moved like this fast. And then if you put something like add more weight on it, look what happened. Yeah, it's getting more slowly, right? Okay, take it away. So that's the 100-ton steel on the top, doing great job. Because the Newton's second the law tells something like, let me see. So the force is static, it won't change, right? Then you add weight. I think this formula tells you add m, and then you will change the a, acceleration. So you change the acceleration, I think it's became like slowly, you won't feel it. So it's actually the comfortable issue, and then it's also help protect the structural joint of this building, because the seismic will hurt this kind of connection. And so this the structure does, and then this diagram tells how that thing move when the typhoon came in, go this way, even go this way, right? So we have the kind of typical regular structure system. This is the core inside. We have a super column outside, and then connect with the outtrig here. So this diagram shows the overall structure system. And then this kind of structure sitting on the mat. So this pipe goes to the earth, I think 80 around like this meter. We have thousands pipe support this mat. So this the picture shows the system of the structure. We have core, we have super column outrigger, and then also the slab. So and this tells the major structure and then the skin structure surrounding the building. So more detail about the structure system, so you can figure out the different color. So we go core first, the piece of steel wall connect with this kind of yellow beam, and then the super column surround, and then we connect with the outrigger, and then also the bell truss connect all those super column. That's the typical the structural diagram for the Shanghai Tower. So we did the test in Beijing architecture science lab. So build this piece model 1/40, and then we passed the test. It works very well. Okay, so let's back to the very early of the design. So I joined the competition team 2006, And before that, we have a bunch of study. So those people come from the Song Society. He's the senior engineer for the Shanghai Tower. He developed the overall system, I think. So the first words about the structure is efficiency. Let's say cost efficiency. Because the investment for this kind of huge project is extremely sensitive. So any decision you do at the early, you impact all the cost for the construction. So any system you use should be simple, regular, and then easy for construction, and then cost efficiency. So he used 10-page and the sketch paper, and then one pencil, did this very early study, and then you can see the diagram at the very kind of concept phase. This building is actually used the square shape at the outside and then round shape inside. And then later we changed this square shape to the soft triangular because there's some kind of suggestion from the wind engineer. I can tell you later the details. And then he also mentioned if you go like the twist this geometry, you have kind of lot of trouble to generate the panel. So you have like on co-plane detail to connect this facade panel. So at the end, I think the goal is cost efficiency, and then you can see what the investment goes to well, structure, MEP, and then like curtain wall and something else. This overall kind of picture tells the cost. So back to the tower itself, we have kind of simple diagram tell the function, the program. So that area is the public space for the retail and then conference center. The green one tells the space is office zone. And then above office zone, the blue one is hotel. Above hotel is boutique office. And then the yellow one is the observation deck. We have 3 layers interior observation deck. And then above the yellow one, we have 1 floor, like 120 level, is outdoor observation deck. It's still on the construction right now, and we have a bunch of wind turbine on this area. So this is the very early the competition image we did for the Shanghai Tower, the rendering. And then we back to some kind of vision about this design. Client give us a challenge is they want this building tell the story about China, about the future, and then I'm sorry it's all Chinese, but I think so. We came out with some idea based on the requirement from the client, and then we want to create some geometry. The form is really unique, and then it's both aesthetic and then technical reliable. We believe this building should belong to all the Chinese people, and then it's also some like the looking forward to the future, also looking back to the past. And so we also came out an idea is what is the vertical city does, because most of the prototype or the development in China is we have a kind of mixed use block. It has the high rise, low rise, public space, some kind of typical downtown picture. So we think like, how can we make the public space vertically and then they can stack in each other? And there's only a few super tall building in the world does this function, especially before the Shanghai Tower be built. So we kind of show this simple diagram, and then we put this kind of space around this building, and it's matched to our original idea. We have kind of circle shape inside, and then we have kind of twist, soft, triangular shape outside. So between these two layers, we have a bunch of buffer zone. And then this zone not only does the public space, it also gives us a lot of benefit to reduce the energy. So the idea is linked to the kind of original Shanghai residential. They have the yard, they have kind of a lot of kind of semi-public space, and then this also shows in our kind of atriums here. So this is the sky garden, and then this is the out layer. And so you will feel it. You go to this space, and then you can feel that something is far away from you. If you live in that second layer behind this glass, you will see the sky or the storm kind of slowing, everything. You feel really safety. You have kind of double layer space helping you far away from this nature scenes. So it's kind of unique appearance. I think a lot of people feel it right now. So you have kind of office space, your workstation in the sky, and then you have the second layer, the garden view, and then actually we do have a traditional garden. I will show you the image later. Yeah, so and another idea is we try create something really kind of special, because for this two building, they have really classical kind of architecture prototype, the symmetric or half symmetric. They like something really kind of has three the division language, and we heard some kind of really good comments from the people living in Shanghai, and then they say, oh, this three building has kind of different character, like Jinmao and then Mori Tower. It sounds like something fly here. It's not belong to the Shanghai. And then that one is like come out from the ground. It's linked to the heart of Shanghai. I think this is the best comments I get from the people. To develop this system, we working with a lot of engineers. So you can see the top line, the structural engineer, I just told you, and then the wind engineer, RWI, they did a bunch of work, the mechanical engineer, and then the life and safety engineer, the vertical transportation, and then the facade. So all the top levels professional guys, they working together. So every week we have kind of weekly regular meeting to talk each topic. So this process runs like 3 years. We figure out all the system. Then we have this view after the final piece curtain wall install. Then you can see the different height of this building. So Shanghai Tower has 632 meters, and then Jinmao Tower has 421, and then Mori Tower. So what's the difference is Mori Tower higher than Jinmao is 30 meters, and then Shanghai Tower higher than the Mori Tower is double, is 140. So this is the relationship between this number. And then you can see the really soft, the geometry tells the really very special for the elevation. You can feel that each side of the building is same character, not like the Mori Tower has that view or another side has another view. I think we get this, and then also client really comfortable with this concept. And then it's not only the aesthetic issue, it's actually come from the wind engineer at the early of the design. They give us kind of 3 really important comments. And they say, okay, this building should be taped if the tower goes that high, and then should be has a round corner, and then with on symmetric geometry. So we did a bunch of study to get this work. So the tape is kind of easy. The rotate create really on symmetric geometry at a different level, and then we working in our SI developed a series of model and then send this to our engineer, especially the wind engineer, to test it. So we also have a bunch of 3D print work to address the design issue. So this model test in Canada has two rounds the testing. The one is based on the small scale to verify the rotation of the tower. So we did the rotation from 90 degrees to 180. And then I think the engineer tell us the truth is small twist of the building, so the wind pressure getting more reduction. But we need balance this kind of different rotation like that one. You can see we send this model to them. They all test in the wind tunnel. So the very good one, I think, is that one. But from the elevation, you will feel this building is too kind of weird, is twisted too much. So finally we picked the 120 as the final number. And then that one show you the result. So this is the test about the rotation. And then we also did a large scale model to test the pressure on the facade. It's tested in 2008, the Chinese New Year, and then in Canada. Then you will see the wind profile at each level. So the wind come this way, and then will create some kind of vortex at the backside. So the negative pressure is higher than the positive pressure. So you can see the movement is go like this way. So that's called the cross movement. So the building in the wind will go like that way, face the wind. And then this diagram tells the pressure of the facade. So the negative one has hot part at the position. You can go to 6.5 kPa. And then we use this pressure to design our glass structure. And then you can see this number 120 has almost 24% reduction compared to the regular shape. What that means is you have less pressure, then you can design more lightweight structure. That saves a lot of money. I think we almost have 400 million for this. Close. Then after this geometry be verified, so we go to the more detailed levels design. Then you can see the inside is kind of stacking, a series of cylinders stacking each other. So in between is the mechanical zone, and the outside glass is twist, also taped. And then in between is our sky garden, is the buffer zone, and then like the insulation of the overall building. And then you have kind of the public space here. This one serves this zone because we have 9 zones. Each zone has 3 kind of sky garden. So this 2-level mechanical zone. So one is the typical mechanical space, and then another one is the refuge. So because people egress from this building, if you're from the top, you will go to the ground, it's almost like 1.5 hours. So some kind of accident happened, the people will go to the refuge area. It's really kind of fully protect. So then the air has some kind of movement in the sky garden. So this will, at the top, the hot air will go to the top of the atrium and then exhaust to outside. So this air is acted like an insulation of the building. And then the typical floor plan. Zone 2, the office area. Zone 5, and then the hotel. So this the kind of another diagram tells the vertical transportation. Because the core, the size of the core is really limited, and they only pry like 27 the shaft, but we have 105, 108 the elevator. So we need kind of really good organize of this elevator. They should stacking each other, and then for some level, like go to the high zone, you need the transfer at the transfer level. So you take the high-speed train to the Sky Garden, and then you transfer the local elevator. So that one is low speed. So this diagram tells the story. So compared to the Jinmao Tower, Moray Tower, and then Shanghai Tower, you can see the size of the core doesn't change that significant. And then, but we have double number the elevator. So we go like this is express elevator, 10 meters per second, and then you take this shuttle to this level, you transfer to the local elevator, and then you land in this certain zone. The good thing is we have the public space at the bottom of each zone. So for some reason, if you want to meet your friend, you want to have a cup of coffee or some kind of food, and then you can go to the amenity level, because this one provides this kind of function. So you are not going to back the ground, use the shuttle. So this reduces a lot of energy for operate this elevator. Yeah, so you'll get the idea is the structure, architecture, and then the kind of the vertical transportation, they working together to make the tower kind of really efficiency. People can really live inside. And then the challenge is the shape. The geometry is twist, taping is not that normal compared to the typical super high-rise. So to develop the system, we did a bunch of work how to kind of define the system, the building scheme geometry. So very early, we did kind of studies. We try to understand what the key input the building should be. So we have like scaling, rotation, and then everything changed by the elevation. So the plan shape really driven by the angle we call A1, that location. So if you change this number of the angle, you get different shape, right? So that one goes really soft. That one, top one. And then the second one is sharp. And then the elevation not that cool. So this shape is balance this two image and then create really good span of the sky garden and then soft geometry and also works with the square meter of the inside. So that we use the A1 angle to draw in the geometry and then did some kind of the rotation study. So after that, we are going to think about the scaling. That one is a little bit kind of chunky because we have kind of simple percentage the taping, or we have the linear taping. And I think this is 2007, I did this sketch, and then came out the idea is if we use formula control the scaling, so maybe we just go to the mathematical way, so not draw everything in tower in the model. We set up the algorithm. So after that, we use some kind of parametric program because the grasshopper just introduced to the world, and then we are the first kind of round people use that program. So you can see the percentage goes to the exponential scaling, and then this formula apply to the tower. So you just need input your elevation, and then you setting up the reduction number. So everything generated in program. So we use generative components early. That one is based on the Bentley microstation system. And as only a few people in China use the program, so we feel that one were not good for communication with our consultant. That I think in first office they use a lot. But we learned something from the generative components, the process setting up the parametric model. That one is really good. So we ran this geometry in generative components, and then later we moved to grasshopper. So we did this study in grasshopper, like I showed you before, this scaling, twisting. And you can see this really issue sketch, like at the top, I think it's 2009. So this group of the component tells the basic geometry. You can see this kind of comments. The yellow pad is the kind of narrative about this different component. And then you just add this different slider, like the horizontal module, and then the rotation, the scaling reduction. So everything on these three numbers control. So that model built up really detailed. You can see the outer skin, and then the inner skin, and we have panel, we have the support structure behind the panel, and then this kind of struts back to the main structure. So if you change this number, so all the model just highly linked, driven by this kind of key number. So you can have this 3D model, you can have the floor plan. Because that when we use this program at that time, it runs really complicated. So we set up the geometry zone by zone. It's kind of help us reduce the time to generate this geometry. Then you can see, you just change this slider to different zone. So anything just generate automatically. We build almost every kind of structure component in the parametric model, including the expansion drawing of the structure. And then all those data can be generated from this model and then sent to the Excel file to format. And then also the CAD program to generate those drafting the floor plan. And furthermore, we developed the facade system because the twist of the geometry, naturally we have the line follow the twisting, so we have the shingle option because if you twist the geometry, this 4 points, they're not in the same plane. They're always 1 point out of the plane. Then it's create a really complicated kind of situation to do the detail here. Because the waterproofing, somehow that's not that easy when you design this detail for the it's not in the same plane, the facade. So to resolve this problem, we also developed some kind of the skin system like cold work. So the panel is not flat when you apply to the facade. So it's fabricated in the factory flat. So when you ship to the site, when you install it, you just push one point attached to the structure. So it's called core wrap system. It's done somewhere in the world, some project use this kind of system, but I think it's kind of risk for us. Even the client, they not agree with this. And for the super high rise, any system should be simple. I think the cost efficiency we talked about early. So at the end, we just say, okay, let's just extrude the floor plan straight, and then we have typical rectangle panel at each level, and then you have stabbing at the interface, the two levels. So that one we call the stack system. That's used for the tower right now. And then this image tells the one system. I think that one should be the smooth system. Yeah, all the definition of the component. And then all those numbers generate at this panel, the yellow one. And then what's good for this program is you can kind of link any input, maybe here, like the nonlinear system. So we found some kind of problem is the panel has conflict with the rust here, because the piper we call curtain wall support structure is actually hanger at the mechanical zone with the solid rust. So this rust conflict with the margin here. Then we just have a shift component here, add to the floor plan, then all the panels shift by this slider. So it doesn't impact any kind of overall model. You just add one component here and regenerate everything automatically. And then all those numbers we grab from the model, and then each panel has this kind of different information like square meter. The smooth option, you need to understand how deep the code, the bending will be. So this diagram is the typical panel, and then we generate this number in the grasshopper like this. So all this number show here, and then you just send this data to Excel file, and then this is the final format for this information. So which zone, which level, and then which panel. And then you have the length, you have the LT1. I think that one is the bending, how deep the bending will be. And then you will figure out the detail, like you need to understand when this bending goes this deep, how the details work. So this model also deals with the digital project. We working with Katia, the company. They give us the 1 month license, and then we did the engineer model in digital project. They integrate the BIM and then also the parametric. Oh, this is my desk. The tower is like dirty work, but the podium, the canopy is kind of fun. So with 1 cup of coffee, we solve. Yeah. This guy has string, looks like. Okay. So something repeat here, so I may go to the next. So this is the canopy built up, and then this logo, Jen from the client, they asked some kind of really good graphic designer did this. So I want to show you some image is the sky garden, what happened there, because we have a lot of sky garden, and then they have a lot of kind of different function there, like temper, And then garden. They really build a traditional garden at, I think that one is level 20. And then some kind of ballroom, the public function area, the really cool space for the ballroom. And then, the elevator. That's the really high-speed elevator for the observation deck. We have 3 elevators from the basement 2 to the top of the observation deck. So each second is 80 meters. Yeah, right now is the record of the world, the fast elevator. And then there's just the observation deck, just finished. And then there's the outdoor observation deck. We have a lot of kind of wind turbine here. Just generate the engineer from the wind. So this is the room of the thing I tell you very beginning, the 100-ton steel sitting here, and then we have the steel frame, and then finally we're cladding by J, the sculpture designed by famous artists in Shanghai. And then this the skylight is the top of the building. Oh, there's something wrong. Sorry. And let's move a little bit to the construction side. So this is the ground of the building. And we did the first piping in 2009, October, I think. And then they just keep piping at the side and dig the hole for the foundation. And so you need have a kind of 6 meter thick the mat put here, and then this dimension is 120 meter. And on this foundation, the concrete mat, we start to build the core steel. Let's go to the upside. And then for the podium, net rest of the tower is the down construction, it's up-down construction. So you can not just build the podium or ground first or then build the tower. It's a safe, like 3 months construction schedule. So the podium tower goes with the different direction. And then when the podium and the basement reach to the foundation level, let's pour another piece concrete at the side, at the outside. And then just keep going, build the system. That's how the rebar work for the foundation. A lot of people. So just out of the ground, 2010, September 28th. After first piping, 22 months. And then 2011, the first 100 meter. Next, 200 meter to 40. And then they start build the typical zone, the steel work. So the contract build everything in Tekla, including the main structure, the support structure, everything in this model. and with really detailed information, because this model goes to the fabricated system. They generate everything from the model. And then you can see our trigger has a lot of kind of piece. We have radiant truss. This truss hanger the curtain wall system. This is the super column, the steel section inside. And then that one is our trigger, double floor kind of truss, double floor height truss. So each column means that piece built separately. And any information has been built, like even the bolt or the detail connection. And this shop drawing generated from the model. So the labor, they build this piece. And then for some reason, the welding or cutting, so this part will never, like the computer shows, they always have some kind of problem, the shape, the deflection. So then you can see that piece has this different kind of part. So they build it, and then they put on the ground in factory, and then they scan this to computer. Because I think before they fix this truss is they build this in factory temporary to test it. But our system is kind of huge. I think nobody in Shanghai can provide this kind of big space to assemble any part and then fix it. So the way is they scan each piece to computer and then assemble this thing in computer to figure out which part is kind of wrong, or they need to cut a little bit, or they need to add a little bit more. And then this thing, when the fixed work finished, they send this to the field to install. So this is the truss or this thing installed like that. And then when the force added to the structural system, they will have a next round deflection. So, and then the guy around this building, they will serve this information back to the computer for the next round, the structural design. So this just like the data just keep going, the build, the fix, install, and then the measure again as the base, go to back to the factory, the design things above, and then install, and then serve. So this keep like the schedule keep going. So that way allow this construction really precise, and then no any part will replace. Especially this structure supported the facade because the structure system is kind of regular. So we use different shape at the outside to generate the geometry. So we can balance the system, like we have regular main structure, and then we have kind of fancy outside scheme. So all the embed was built in factory, and then the manufacturer, they use our formula to generate this geometry, and then they test this in factory. It runs very well. I think this first time the design model directly go to the fabricated system. It's build a link, something between these two areas. So there's something server the structure around this building, and then the facade contract also will scan this panel after the fabricate to the computer, and then they will compare this data in computer, like structural data, facade data, and then to figure out this any kind of conflict. So the process of the installation goes really well. I think they spend 15 minutes install one piece panel. No panel has been replaced. And then this the final piece panel. Yeah, this only conflict happened at the top. Because when the building goes to this level, the overall things just going down like 10 centimeter, 4 inch. So the panel, I think some kind of mistake happened. So panel fabricated based on the original elevation, and now all the structure of the main structure raise up 10 centimeter to absorb the torrents. So that piece cannot install like that time. So I was there waiting almost 4 hours to install the final piece. So typically 15 minutes, but the final one is 4 hours. It goes like evening. That's the final one. This kind of traditional way, they have a red flower on, right? And this is the image of the 3D building after construction. That one not so good. I don't like it. So canopy is good, it's warm, very welcome. And right now when you back to, when you kind of keep a little bit far away to look at the building, this twist geometry, it sounds like the dressing of a very traditional Shanghai dressing. It's called qipao. I don't know how to speak this in English. They have some kind of line go like this way, right? This qipao, yeah. So that's the overall story about this building. I think, I don't know, is share my experience from 2007 till this January. I moved from Shanghai to San Francisco for the internal transfer and will be stay in American like couple of years. Have a kind of different experience. I think I will, and open something for me, like different eye, meet different people, and share my story, and also want to listen to you guys, and just for fun. Yeah, that's it.
Any questions? Oh, okay, I saw that first.
Hey, so I'm wondering why you choose Grasshopper for the software and over like Revit or CATIA or some other sort of software. Could you talk about what you thought was beneficial about using Grasshopper and Rhino, and like why you chose that one?
I think at the 2009, we really have some kind of, we feel really difficult to have a kind of really good study in the program we have at that time. I think we do use Revit and 3D Max and kind of generative components, Rhino, to develop the system. But we get a 1-week workshop from the Bentley. They give us kind of introduce how to use generative components. And then this opened the area for us. Like you can think about geometry. It's not the typical modeling way. You think about algorithm. You think about the process. And then you can kind of lead in the system in very high level and not really to build it with your mouse. And then we learned this from generative components, but we made some kind of problem is communication. It's really hard for communication. The data generated from generative components is dead. You need send this kind of DXF model to your consultant. It's not that different like the we do in any kind of program. And it's really, I don't know, it's accident, I think, happened. I just browsing internet with Google, And at that time, we don't have grasshopper3d.com. It's only a Google group. There are a lot of people there. You just post your question. Oh, that's cool. And then oh, how I can mirror this line, and how I can generate this plan. And you just post a question, and then a lot of people there to answer. That's the kind of first called Google group. And then the program is not called Grasshopper. I forget the name. It's another name. Yeah. And then we found this kind of really benefit is much more kind of benefit than we expect. It's good for share, and then the data is you can grab any deep levels data from the model if you want. Yeah.
Thanks, Michael, for
Yeah.
the fantastic overview
Yeah.
of the tower. I was following it for a while now. It's great to see it finally completed. In regards to towers, usually we experience it or we see it as the entire form. And so a lot of times it escapes the mind of how does the tower meet the ground. And I know in this case, on one side it meets the ground with the same logic. On the other end, there's this big, shiny conference convention center. And so I was wondering if you could give some insight on the dialogue, the design dialogue that happened on the question of how the tower touches the ground or meets the ground.
Yeah, I may need to find a good image to. Yeah, so I think the plan, like this is the tower hitting the ground, and then the function of the ballroom, I should show you a very shiny one, is actually happen at this area, and then face to the Jinmao Tower, and then also has a on the ground connection to the subway. So, and then this side, because it's all residential, so the site is quite limited, and then has really strict requirement about the green ratio. We need tree, the lot of kind of landscape, keep the open space like the green. So that side is actually totally the retail conference, 5-floor podium, and then 2-level basement also has the retail directly connect with 3 next to super tall building and the subway. So the ballroom, I made some stories. We did the public space interior design, and then the client say, the ballroom looks not that cool, so they just open a second round competition to the world. And then we win it again. So the DC office come to Shanghai, did the competition, and then they get it, and then build it. Yeah. And then the podium has gold facade, not like the tower has kind of typical kind of super high-rise glass building. Yeah. I don't know if this is kind of match your requirement. Oh, the ground. I think a lot of kind of comments it says the ground is like forced because the Jinmao Tower and the Mori Tower, they have less tree. They're all stone paving. So people like it because it's something like the building growing from the frost. It's really good. And then SWA applies this kind of concept. Yeah, they say that will be kind of cool if this can like compare to the next 2 building.
So you had this great diagram which showed the tower within the city and then the tower as the city. And I was wondering what design strategies you use to achieve this goal of a city within the tower, and do you feel that's successful, that there's a sense of community within the tower?
Yeah. This image, let's say that one. I think this amenity floor around this tower, we have 8 different kind of public space. The one at the 52 is the largest bookstore there, and it's open right now. So this bookstore is called, I don't know, it's from Taiwan, right? Yeah, it's really famous. They not only sell book, they sell a lifestyle. And then we have one at the 52, and then we have another one, the same brand. They have a big space at the basement 2. And then that one is open to the public space and also linked to the subway. So we have museum at level 40. I think it shows some kind of collection for the China traditional art. And then we have also the famous restaurant at different level. So all those things is open to the public. It's not like the building nest. They need very security check. You are not allowed to the area. They don't provide this kind of public space. So if you apply, you can go any kind of levels, public space to enjoy your life. You have a cup of coffee, look in the view, you buy a book at that level, and then maybe you visit the museum at next level, and then enjoy the traditional garden, the picture I show you. So this is a kind of organic system, and then it happen at the super top building. So yeah, so we use this thing to express our original idea, how talk with city, how kind of bring this kind of public levels, the function, the area, to all the people living in Shanghai, even in the world. So I have been in Shanghai October or August. I just follow the people, go to the observation deck, just try act as a tourist. And then I find the people really love the curtain wall, this area. We have really deep marlin, and then we have really kind of deep step. The people just sit there and then silence, really silence. They just look the city, like half hour without any words. Really folks, each one has one space. It's really good feeling to me because this is not part of the design scope. You say, oh, this curtain wall, stepping, but people love it. They just sit there and then look.
I just want to add one for the comments for her. Also, on the top of the building is not observation deck with the giant kind of metal thing. That's a world first 5D theater, and only play by sound. And you can hear the dimension of the sound. You can close eyes. It's very dark. So yeah, we're all waiting for its official open. We can see the first show. And also the composer who passed away, what's his name? James Cameron? James Horner. I'm sorry, James Horner for Titanic. He actually wrote a piece of music for the building. So it will be shown in the theater, totally on the top. So it will be really fantastic to see. Also, it's kind of also that's the place. That's the theater. It's not traditional. It's just observation deck. Also, the bookstore he mentioned, the Taiwanese elite bookstore is open 24/7. So also they try to introduce that for this building as well. So it's just a non-stop, just 24/7 life. Okay, another question.
So my question refers to the facade. I was wondering, besides the airflow, how else did the context of the site affected the change, the shape, the angle of the facade?
Please, sorry.
Oh, I was wondering, Besides airflow,
Yeah.
how else did the context, did the site change the angle, the material, or anything that's related to the facade?
As this kind of wind issue is really can determine the design, because in different area, like if you live in Beijing, you build the super tall building in Beijing, I think the seismic will be the major issue. But if you build this super tall building in Shanghai or in some kind of typhoon zone, like I think the Taipei 101, right? So the wind will become like extremely serious issue. So we did the test, we get the pressure, and then based on the pressure, we designed the glass structure. So all the glass structure is actually based on the wind tunnel test. So especially the negative pressure. It's really high, you will feel it. If the detail not designed very well, the glass will throw away when the typhoon happens. Yeah.
Over here. So the president's comment was no more weird architecture in China and the area. And also I was wondering, you didn't have any residential zones in your building. So what would have happened, how would the design of the building have been changed if you had residential zones in the building and if the president hadn't made the comment of no more weird architecture?
Yeah, I think the really early we have apartment program on the top, not the hotel. That's the original design, and then at the back they changed the residential. It's true, it's no more weird architecture not even in Shanghai. It should be entire China has this kind of requirement from the chairman. No more weird architecture, right? If we go to residential, I think the view will not change too much. But what changes is the vertical transportation system. Yeah, and then I think you need have the different layout for the people living there, or not, or hotel, or people visit there like a hotel. Is different requirement. So I think the people living in the second layer curtain wall is pretty much same experience when you live in a hotel. So the all facade or system, like from the outside, will not really change. Yeah. And I think still, before I live in Shanghai, come to San Francisco, they still open the topic. Maybe we can change the hotel to the apartment. So that's why the hotel is not fully developed right now. We did this kind of study in our design phase. That's true.
More questions?
So in New York, at least, what we're seeing a lot for skyscrapers is like curved edges. You say Shanghai, like it's also like the current trend.
Pardon? I can hear you. Sorry.
So like for like high-rise and skyscrapers in New York City, what we're seeing a lot, like the current trend is like round edges, like on the building.
Yeah.
Would you say that's like also a trend in Shanghai or not as much? Like is it more eclectic or like what have you seen as far as like has there been a lot of like limitation in this project? Or I guess it's too soon to say.
So you mean the limitation of the developer, this kind of glass shape?
Like the curved edges, like
Yeah.
is that really like typical of like the current trends in Shanghai as far as like skyscrapers go?
Yeah. As the geometry is really driven by kind of design concept and also the engineer recommendation, right? I think at the early, you can see the building is kind of square shape in the sketch, and then I think at the really early, we have two square shape, the outside square and then inside square. They twist together, and so we kind of talk with the engineer at the first round, some kind of comments is, maybe we can keep the inside not rotate, only outside rotate, so that's why the inside become circle shape. And there's more and more comments from the engineer says, okay, the twist is something impress the culture like China and dragon, something like this. And the really sharp corner does not help for the building at this tall when, especially in the wind zone. And then we have square shape with the 4 soft corner. And then I think the exact time I can't remember. So we go from 4 soft corner go to 3 soft corner. So that model generate is become like the number is 3. So it's reduced a lot of kind of the steel structure for the sky garden. And then the 120 degree also introduced to this model. So it's really tells the story about Shanghai. We have 2 rivers around the building, the Huangpu River and then Suzhou River. So they all kind of around the shape. I think this really built the connection between this design and then the local culture. It's not only the buffer zone and also the geometry itself. Then you can feel it now. A lot of people come to the building to see this kind of twisted things. Yeah.
Okay. You can speak now. I have a question, but it's more like contextual at all. I'm trying to wonder at what moment this building is so big that it becomes a city, and it's mostly like you're privatizing a city, and what's the relationship of privately owned so much square footage in the city of Shanghai and the context of how it relates back to the government and the city. Because I'm not sure that having that much square footage privately owned is beneficial for a city. So I'm trying to understand what's the relationship of the conversation that you guys develop with the city of Shanghai to develop that much square footage and privatizing one whole building as a city. It's pretty much you guys are, it's privately owned one entire block that extrudes 120 floors, right? So I don't know if you can talk a little bit about that. What's the conversation that emerged when you guys are trying to negotiate the city and setbacks, and how much do they have control over your building, or how much are you willing to give control over that?
Mm-hmm. And this urban planning is actually happened 1991, and the 3 super high-rise should be there, and the first one is Jinmao, the build really fast. It's kind of hard to explain with the typical kind of academic level to talk about the urban planning. I think it's something like the people or the leadership in China, the government, they want to show something. And then if you compare the image, the Jinmao Tower built up, it's super flat at this area, and then you have only one building. So I first time visit the Peng to see this building in 1994 or 5. It's really impressive to me that Jinmao Tower looks so shiny. You can't see anything else. Just one single object without any the things around, or only the broadcast tower. And so it's kind of hard to say, okay, this is the pure urban design, but we try our best to build the relationship between this building and then the city. We give her a little bit soft shape and then some kind of nice, elegant detail. We should tell a story, a little bit piece, not that sharp like the something like a lot of people kind of comments the Mori Tower, right? like braid, something like this. Yeah. Then you can understand why the leadership in China, they try to tell the world, okay, this country growing like this. I think, yeah, it costs a lot. So people will say, oh, it's really kind of efficiency like this. Yeah, it's really friendly to the people, but we try our best, I think.
I can give you a little bit just add on. The image he showed for the rendering 10 years ago is not what looks like right now. And there are at least 40, 50 different high-rise buildings along the riverside, on the east side of the river. So you see that, they imagine that only the 3 buildings and just standing up. That's 10 years ago, but right now, totally changed. And so right now, every year, the housing price reach another kind of higher kind of level almost every year. So in Shanghai, we just expect the housing bubble happen, but it doesn't happen. And also another really interesting story. So you have to know the background. The first building, the 3rd tallest building, Shanghai Tower, is invested by American company, and so that's why the Grand Hyatt Hotel is in there. And also the 2nd building was invested by Japanese company, 2nd building. And then they faced the financial crisis in 1997, so they dig into the foundation. The foundation was there for 7 years, not moving. Then another company, I think still Japanese, they purchased the land, and then they finished the construction. And then the 3rd land, the tallest building right now, is developed by Shanghai government. So it's like from, so you can see that the economy changing. So they have to show this as we are developing this building, this kind of palace. This is the best thing around the world, totally by ourselves. They don't want to use any foreign manufacturers to do this. Also, Shanghai Tower, they have their own American contractor. They have American kind of material suppliers. So the building is super expensive, but very fast. Everything was prefab in the US, then they ship there and install very quickly. And so the 3 buildings really represent the 3 stages of the development of Shanghai during the past 20 years. So it's also kind of interesting. So that's Chinese way. So even the first one, American, they design, also they develop the site, they try to make it like Chinese pagoda. And the second one is very controversial because in the beginning it's designed on the wrong shape in the top, like the Japanese sword holding the sun. Then it was controversial, they had to change the shape to a square shape. And then this is called, that's just the current face. This is the facing for the future. It's kind of formless compared to the other 2. So many interesting happened, but eventually the 3 buildings all designed by American firms. So.
Yeah, and then the Shanghai Tower, I think only the sand is produced in China. Yeah.
Yeah, so there's a lot of really breaking through kind of technology and also really interesting thinking for the tower, but also they face a lot of problems as well. So that's a really interesting thing to see what will happen in the future. Okay, I think that's it. So if you have more questions, just ask him just afterwards.
Yeah.
Okay, let's thank Michael again.
Thank you.